In this session, we shall discuss on the topics magnetic field at the center of a circular current carrying conductor অর্থাৎ একটি বৃত্তীয় পরিবাহী তারের কেন্দ্রবিন্দুতে চুম্বক ক্ষেত্রের মান নির্ণয়। For that purpose, we are drawing a circular current carrying conductor. Suppose this is a circular current carrying conductor and this is the center C where we want to find out the magnetic field. অর্থাৎ আমরা C বিন্দুতে চুম্বক ক্ষেত্রের মান নির্ণয় করতে চাই। A current I is flowing through the conductor in the clockwise direction. Now, to apply the Biot-Savart law, at first we have to choose an elementary length. Suppose this is dl is the elementary length. Now for this length dl we have to calculate the magnetic field at this point C. Now to find out the magnetic field at C, we are connecting dl to the point C. Let A is the distance from dl to C and A is the radius of this circular wire. অর্থাৎ বৃত্তীয় পরিবাহী তারের ব্যাসার্ধ হলো A. Now according to Biot-Savart law, we know dB equal to mu 0 upon 4 pi I dl sin theta. But here you see, what is theta? Theta is the angle between the elementary current element and the line joining from current element to C. অর্থাৎ আমরা dl এবং a radius এদের মধ্যেকার কোণের কথা বলছি। Now you see that here this angle is 90 degree. So we shall write here 90 degree. So dB equal to mu 0 upon 4 pi I dl sin 90 degree upon a square. Therefore, this will be equal to mu 0 I upon 4 pi a square into dl. Now, to calculate the magnetic field at this point C for the whole circular conductor, we have to integrate over dB. So total magnetic field at C is B equal to integration over mu 0 I upon 4 pi a square into dl. That is equal to mu 0 I upon 4 pi a square integration over dl. Now, what is the integration over dl? You see, the integration over dl is nothing but the integration over the whole circular conductor. So this will represent the total perimeter of the circle. অর্থাৎ dl এর উপর ইন্টিগ্রেশন হলো বৃত্তটির পরিধি। So this will be equal to mu 0 I upon 4 pi a square into 2 pi a. Therefore, total magnetic field B will be equal to mu 0 I upon 2a. This is the total magnetic field at the center of the circular current carrying conductor. Now, from this formula, we are getting only the magnitude of the magnetic field. But we know that magnetic field must have some direction. So how we can find out the direction? We can find out the direction from the vector form of Biot-Savart's law. And in this circle, this is dl, this is the line element. Now the cross product of dl and this vector will represent the direction of the magnetic field, and here if the current is in this direction, then this will be the direction of magnetic field. Cross mean this will be perpendicularly inward to the plane of the page. Now here we are considering only one term, অর্থাৎ আমরা এক্ষেত্রে বৃত্তীয় পরিবাহীর একটি মাত্র পাক সংখ্যা নিয়েছি। যদি এক্ষেত্রে একের বেশি পাক থাকে, দ্যাটস মিন if the number of turn is more than one, then we have to consider that also, and in that case the magnetic field will be B equal to N mu 0 I over 2A, where this N is nothing but the number of turns of the coil. Thank you. Now we shall discuss the magnetic field at a point on the axis of a long solenoid. অর্থাৎ একটি সলিনয়েডের অক্ষের উপর কোনো বিন্দুতে চৌম্বক ক্ষেত্রের মান নির্ণয়। In this video we shall not derive the expression, but we shall only write down the expression. Let this is a solenoid through which a current I is flowing, and this is the axis of the solenoid. We want to find out the magnetic field at a point P, which is on the axis of the solenoid. Now if we calculate this magnetic field using the Biot-Savart law, then we shall get B equal to mu 0 N I, where mu 0 is the permeability of the free space, N is the number of turn per unit length, and I is the current flowing through the solenoid. Now this law is applicable only if we consider an infinitely long solenoid. That means if the solenoid is finite, then this formula will not be applicable. অথবা যদি খুবই দীর্ঘ কোনো সলিনয়েড হয়, তার ক্ষেত্রেই আমরা এই ফর্মুলাটি প্রয়োগ করতে পারব। Now if total length of this solenoid is N, and if total number of turn is N, then small n, that is number of turn per unit length, will be total number of turn divided by the length of the conductor. So this is the magnetic field at a point on the axis of a solenoid, and the direction of the magnetic field can be obtained from the direction of current in this solenoid. Here the direction will be along the axis in the rightward direction.